All right. So in today's lecture, we will be just determining different materials for a room. Okay. We have this small project, you can say, and we will be just working the quantity of each material and actually those material which can be used in the construction of a single room. Okay. I drew this drawing for you guys just maybe an hour ago. And as you can see, we will be just calculating from foundation till depth, you can say till the top or maybe till the roof. Okay, as you can see, we have, you can say, PCC work, then we have the stone work, and there is about something about the floor. Okay, and then we have brick work, as you can see, and then there is of course the roof. Okay, we got a 2D plan, and there we have the foundation plan, and then the front elevation. Now this section is actually about AA. You can see this. Okay, if I select it. Okay, so let's move ahead. And in order to calculate all these materials using whiteboard, it will be a little bit complicated. Okay, that's why I'm going to use an Excel sheet. Okay, here we got an Excel sheet. And normally, okay, people use it. Okay, doing calculation manually, that takes a lot of time. Okay, so let's get started. And let's say if we have the first thing which I'm going to do is actually just to prepare an Excel sheet for myself. So I'm going to say the material estimation for a, you can say for a room, okay, which is, you can say 12 by 12, 12 times 12 feet, okay. So this is the thing which I'm going to do in the same video. And after this, if we got some time, uh, we will have some analysis related to materials. Maybe we will analyze PCC work, okay, and then maybe some plaster work. And we will be just determining the quantity of cement, sand, and then the quantity of crushed stone and the water used in PCC work, maybe, okay. So we will just see if we can cover the room first. Okay, so material estimation. And if you remember, we always just provide the serial number first, and then of course we have the numbers. Okay, and there we got the length. If you remember, the quantity or maybe the volume of something can be the length times width times its, you can say, height. Okay, and then times the number of members maybe. Okay, so I'm gonna say the length, and then we have actually the breadth or width, you can say, and then we have the height. Okay, and then we will just calculate the quantity, okay, and then remarks. Now, in order to determine the quantities for different materials, let me just make some, you can say, let me just give it, oops, just a minute, some borders, you can say. You can give them borders, okay, all borders, so we can see these things. And let me just select this, and I'll have this style, and then maybe time new Roma. And for this thing, as you can see, I'm gonna have little bit, let's say 14 or maybe 16, okay. And this is actually something, what's going on over here, something is wrong over here, okay. So we have material estimation for a room 12 by 12 feet. Okay, now I'll just double click over here so we can see the writing. Okay, make sure you are a little bit familiar with Excel so you can have access to all the functionalities or maybe commands. Okay, all right, now let me just have AutoCAD open over here, and as you can see we have this 2D plan. If you see, is it clear? Please somebody can confirm it. Do you guys see it? The foundation plan or maybe the 2D plan?
यस सर। सर एक सवाल है।
Yes.
सर आज दोपहर को ज्वाइनिंग नहीं हुई थी क्लास में तो ऑटो कैड की, तो ये जो अभी रूम का जो डायमेंशंस वगैरह हैं तो ये आज की क्लास में हुआ है।
नहीं नहीं, ये हम करेंगे इंशाल्लाह बाद में। आज सिर्फ हमने वो लेयर्स को डिस्कस डिस्कस किया हुआ था, ठीक है।
ठीक है सर।
Okay, so now there can be different methods in order to determine the quantities, like maybe the center line method, and there can be elementary methods. Okay, there can be long wall and short wall method. Okay, and I believe you guys have heard these terminologies before. Okay, so I'll be just using the long wall and short wall method. As you can see, I have already labeled the walls, okay, with wall A and then wall B. Okay, now let me just pick my pin so I can make sure that you guys understand about the long wall and short wall. Okay, I'll let me just have maybe whiteboard. Okay, share. What do you mean by the long wall and short wall? Okay, the whiteboard is loading.
सर शो
And
नहीं हो रहा.
wait a minute, it's loading. It's just loading.
यस सर. ओ.
Yeah, it's done. Okay, so we have this whiteboard. And what do you mean by the long wall and short wall method? Okay, you guys can see the whiteboard.
यस सर.
Okay, let's say we have a room like this one. Just ignore the you can say the style, maybe the drawing. It is not according to the scale. It is just NTS. NTS means not to scale. Now, this room is actually, let's say, 15 by 10 feet. Now, what do you mean by the long wall and short wall method? As you can see, we have two types of walls over here, okay, according to the length. And if I change the color, as you can see, let's say if I extend this line to this point and then that one, okay. So if I shade this one, like let's say, okay, I can just call this wall is long wall, okay, because it is just lengthy with respect to the other one, okay. However, the remaining one, which is this one, this can be just termed as the short wall, okay, because its length is just shorter, right? It means we have two short walls and then two long walls. In order to determine the length of the long wall, it is very important, okay, that you should have the thickness of the wall, maybe let's say 0.9 or maybe 9 inches only. Okay, now let's just see if we can determine the length of the long wall. Okay, so the length of the long wall, you can say length of long wall, or I'll just annotate this with LW, which means long wall. Okay, now as you can see, we have 15 feet over here, which is this distance. If you see, this is just 15 feet. Now, for the long wall, we will just add the width of the wall for one side and the width of the wall for another side. Do you guys see it? Okay, it means the total length of the long wall is now 15 feet plus one wall width, which is actually 9 inches. Okay. And there we have another 9 inches for the other side. So this is the total length of the long wall. Okay. It can be anything, no problem. I'm not gonna label that. Now the short wall remains the same. Okay. The short wall is actually just the same thing. Okay. From this point till this point, and it is just 10 feet. Okay. So this is actually the basic concept of determining the length for the long wall or maybe short wall. Okay, I'll again jump into the AutoCAD and Excel.
सर ये 9 इंचेस की जो है तो ये इसमें एक्स्ट्रा ऐड होगी.
Yeah, exactly. And that is just because, as you can see, we have extended the long wall's length, okay? Maybe we're here, this corner is also added, and that corner is also added. You can see that, okay? So that corner is actually 9 inches, and this one is also 9 inches. That's why we are adding 9 inches to both sides. Let's share the screen, okay? What about now?
Yes, sir, we can see it.
Okay, very good. Now, as you can see, we have serial number 1. It means, let's just say if we need to determine, okay, something we're here, I need another, you can say column, okay? So I can insert, we're here for the description, because description is very important, okay? And that is because of the analysis. Now, after the estimation or maybe determining volumes, areas, we do analysis. So description is very important for that analysis. All right. Now, let's just say if we need to determine the earthwork or maybe we call this in excavation. Okay. And you can also just type in ordinary soil, okay, just for the sake of the description, okay. You can also, if you are a little bit familiar, okay, I'll also teach the functions, okay, and how we work in Excel, okay, because um, becoming a quantity surveyor and you don't know about in Excel, it will be a little bit hard for you, okay. So select this cell, and as you can see, you can wrap the text, okay. So as you can see now, the text is just wrapped, and you see it, okay. It's good. All right. Now, excavation can be different, okay, for each wall. Okay, that's why let me just say if I need to determine excavation for wall A, and then I'll determine excavation for wall B, because we have different, you can say wall A, that is just the long wall. You can just make that short wall, does not matter, it depends on you. Okay, so let's say if this is short wall, no problem, and I'll call the wall B is long wall. Now this is square, okay? And square is something whose each side is just the same in length. So that's the reason we have some difficulties over here. Now, as you can see, if I need to determine wall A and I have taken wall B is long wall, it means, let me just have something, wait a minute, okay? Let me just change the color to yellow. Okay, now let's see. I mean that the length of the long wall should be extended to this point and then this point. Okay, and let me just make it little bit shady for you so you can see it better. Okay, I can have shared, you guys can see it. What about you? What about this now? This is actually something, okay, let me just say, if I have annotation and then linear, we have 12 feet this guy and 9 inches this one and 9 inches to the other side. It means this is the total length of the long wall. Is it clear now?
Yes, sir.
सर एक सवाल है सर।
Yes.
सर ये आउटर वॉल जो होती है फाउंडेशन पे भी यही अप्लाई होती है? इनर साइड हमारे साथ 12 है ना?
Yeah, this is just actually foundation can be you can say lengthy. Okay, we will increase
ओके
the length of the foundation because if you look to the foundation, as you can see, we have other steps and those are actually just extended. Okay, as you can see, this represents the wall. However, this step is just extended. So I'm not just doing that yet, okay? I'm just showing that the actual length of the long wall is now 12 feet, 9 inches and 9 inches, which means 13.5 feet, okay, is a total. And you can confirm it, okay? Let's see, outside to outside. This is just 13.5. Okay, 13 feet 6 inches means 13.5 feet, because 6 inches can be converted if you divide that by 12, okay, into feet. Okay, just divide any inches by 12, that will be just converted into feet. Okay, this is just basic, you understand it, I guess. Okay, so it means the length of the long wall is 13.5. However, these both, okay, in number I can say these both are 2 in number. That's just clear, okay? Everybody understand it. All right. However, the length of foundation is, as you can see, we are calculating excavation, so the length for foundation can be different. We are not gonna have 13.5 this time, okay? Now, what should be the length for the foundation? Okay, I'm just gonna say, let's say there is a nice method for that. Okay, just focus on the cross section over here. Okay, the width in the cross section, that is 13 inches. We will just subtract the width of the wall. We will just subtract the width of the wall from the width of the foundation. It means 13 inches minus 9 inches. And then we will add the length of the wall. So this is going to be the length of the foundation. Is that clear? I think that's
सर
clear.
दोबारा नो
No, sir.
सर रिपीट कर लें इसको।
Okay, I'm trying to say that the weight of the foundation, that is 13 inches. We will just subtract the weight of the wall, which is 9 inches. You guys can see that. Okay, if that is small,
यस सर।
let me just scale that. Is it clear now? So basically what I'm gonna say is the length of foundation is going to be the length of the wall, which is 13.5, if you remember, that is 13.5 feet. You remember that, okay? And we will just have summation of this ratio, okay? We will subtract the wall thickness from the thickness of the foundation, or maybe weight of the foundation. Weight of the foundation, that is 13 inches, okay? And we will just subtract 9 inches because that is just the weight of the wall, okay? It means, okay, if I just simplify this, it means 13.5 feet minus 13 inches, okay, and minus 9 inches, that is actually just 4 inches, or maybe 4 inches means 0.334 feet. And this is actually addition, okay, we will just add them, not subtraction. All right, it means 13.5 plus that thing, that is now 13.833, okay? So we will take the foundation length is 13.833. How? Okay, let me just have a little bit detail over here so you guys can see it. Okay, let's just look to this thing little bit for a moment. Okay, this is the foundation plan, and I'm gonna extend a line from this point till that one. You can see that, okay, externally. So this is going to be the length of the foundation, and let's see if it is just the same thing or not. Okay, so we will have, you can see it, 13 feet and 10 inches. What do you mean by 10 inches? Let me just have calculator. So I'm going to just have 10 inches and let me just divide it by 12. And that is actually 0.833. Now I'll just add 13 feet, okay, plus 13, it means we have 13.833, okay? So this is going to be the length of the foundation for the same wall, for the long wall, you can say, okay? If you don't understand what's going on, so I can switch into the whiteboard. What do you guys say? Okay, should I switch to the whiteboard?
Yes, sir.
Okay, let's see what's going on in the whiteboard. Okay, here is the whiteboard. And let me just have an example over here. The weight of the foundation, okay? Let's say we have a cross section like this for the wall, okay? And let's say this is maybe 60 centimeter. And let's say the weight of this wall is 30 centimeters, okay? Now we have the, maybe the map like this, maybe the drawing like this, okay? And as you can see, this is the long wall. You can see that. That is the long wall, okay? Now, the length of the long wall, we have already determined that is just 13.5 feet. We have already determined that, let's say. Now, the length of the foundation, as you can see, the foundation can be for the same wall. If I change the color, just focus on the red color, okay? The foundation for the same wall can be just in this form, okay? It means we have increased the length for the foundation. How much are we increasing that? That's the point, okay? That is actually just this step, and for the other side, we have just added these 2 steps. And those steps can be determined if you subtract the wall thickness from the weight of the foundation. Is it clear now? I have taken these things in centimeters, okay? So that's why this is the reason you guys don't understand. Let me just have the length of the wall in other units as well, okay? Let's say the length of the wall, that is just 3 meters. Oh, okay, just a minute, 3 meters, okay? Now, in order to determine the found, wait a minute, just a minute. Let's say if we have a straight wall, what do you say about this thing now? If we have a straight wall and the length of the straight wall is 3 meters, okay? And we have a cross section of the same wall, and let's say the cross section, that is just, let's say 60 centimeters wide, and the thickness of the wall, let's say this is just 20 centimeters, okay? Now the weight of the you can say foundation, that is 60 centimeter. Okay, we have another color, and let's say the foundation length can be just in this form, okay? Now, this thing is actually just this thing. You can say the wall in the section. This is the wall, and here this is the wall. Okay, this thing actually represents the first step, and for the another step, you can say the bottom one. Let's say I'm gonna draw another you can say line like this one. Now we have actually the length of the foundation, which is just this thing. Okay, so that should be actually the length of the wall, which is 3 meter, plus the you can say the factor which I have is actually 60 centimeter. You can say the weight of the foundation, that is 0.6, and we will subtract the thickness of the wall, which is 0.20. Okay, it means this is going to be the length of the foundation. It's very simple. Now 3 plus just 60 minus 20, that is actually 40 centimeters. Okay, so we can say 0.4, and that is going to be now 3.40 meters. So this is going to be the length of the foundation, okay, which is actually just from this point till all the way to the end. What do you say now? Are you guys okay with that? If you guys
Yes,
don't
sir.
understand, if you don't understand, I can even draw this thing in AutoCAD in 3D model. But I think you guys are now clear.
Yes, sir.
Okay, good. Now, let me just again jump into the AutoCAD and then Excel. So in the just focus on the Excel sheet, okay? Now, the width or the breadth of the foundation, okay? You can see that in the same drawing, that is 13 inches, okay? Now, you have to divide that 13 inches by 12 inches to have 1.083 feet, okay, is the width. Now the height of the foundation, okay, where do we excavate and how do we excavate? Can anybody explain that?
2.5 feet,
Actually,
sir.
actually, you have to look to the ground level, okay? It depends on the ground level. We always dig below the ground level. So how much below are we digging? That's actually the depth of the foundation. And you have to look to the ground level. Look at that. That is just the ground level, okay? You can see GL means ground level. And this is actually the same line like this red one. So we have to just count all the depths below this line. That is 15 inches and another one that is actually 3 inches. 15 plus 3 inches, that means 18 inches. 18 inches is just actually 1.5 feet. That's simple, I think.
Right.
So that is just the depth of the foundation. Now the quantity, if you remember, okay, that's why we had just uh, wasted our two classes on the volume and area calculation. Now here the quantity is actually the volume. And in volume, it means the length times the width times the height. That's going to be the quantity or maybe the volume, okay? So you have to apply a formula like maybe this thing, okay? We will just, you can say, multiply this with the breadth times the length times the number of the walls, okay? And press enter, okay? That is 44.94. Now, the quantity can be just in CFT or maybe, okay, I should have another column over here for the unit. So the quantity is now in CFT. Okay. In remarks, we can say that, let's say if we have 13, okay, that is 13.833. So how that comes? It means that is just from the, let's say 13.833. Okay. That is it just actually from the same thing is 13.5 plus we have just subtracted the you can say weight of the wall from the foundation's weight. Okay, now the foundation's weight, that is just 13 inches. Okay, what do you mean by 13 inches? It means just you can say 1.083 feet. Okay, and we have just subtracted 9 inches from that. So this is just remass. Okay, you can understand that if something is wrong, like maybe if you're confused with 13.833, so this is the same thing as this one. Okay, now we will actually decrease the length of the short wall. Oops, wait a minute. We have calculated long wall. Okay, so that is just for the below one. It was for the long wall, if you remember, guys. Okay, now we will calculate the short wall's length. Okay, let's again jump into the AutoCAD. Look at that. Okay, if we have long wall, let me just copy this thing again from that point till this point. Now the short walls, if I can just see the short wall length, let me just erase these things. The short wall remains the same as 12 feet. As you can see, this remains 12 feet because from that point, let me just have some dimensions and then linear from this point, maybe you can say till that point, it is the same thing, okay, 12 feet. However, the foundation length should be decreased because some parts of the short wall are already taken over there. Okay, how that works? Let me show you. We're here. Okay, let me just erase this thing, and the center line so you guys can understand the problem better. Now, if you see, if I just need to draw a rectangle from this point all the way, like maybe till this point, okay, and let me just as you can see, some parts, like maybe this part was just included in the short wall, if you remember. However, in excavation that is already taken, you can see the yellow border, okay? This point is already taken. Similarly, this point can be taken to the other side. It means this time we will be just subtracting the you can say that ratio. Like in the previous thing, you can see this thing, okay? This time we will be subtracting, not adding with the length of the wall, okay? Like let's just see how it works, okay? So the breadth, that is the same thing, okay, for both. So I can just copy that and paste it over there, okay? The height is same for both because foundation can be just the same height, the same width for both walls, okay? However, the length can be changed. And how? Let's just see how it's going to be changed. Okay, so the length of this thing can be actually, we will have to subtract 9 inches, which is the weight of the wall, from 13 inches, which is the weight of the foundation. That's clear. We will just subtract this thing is this one. However, this time, as you can see, we have addition over here. Instead of that, we will have subtraction. Okay. And this is actually 12 feet, if you remember. It was just 12 feet is the short wall. So what should be the length of the short wall's foundation now? If we just do the same thing. And let me have a whiteboard so you guys can understand this thing a little bit more. Let's say if we have the same, you can say wall, you can say the short wall. Or let me just draw the same drawing again over here. Okay. So for the foundation, I'll change the color. Now, for the long wall, the foundation was just the same thing like this, if you see. Okay. For the other side, it was just the same thing like this. Now, short wall, the length of short wall was just, you can say from this point till that point, and it was only, you can say 12 feet. Okay. However, we cannot take 12 feet as the foundation length because some parts, like you can say this part is already taken with the, you can say long wall. What do you say? These parts are already taken with the long wall. Okay, so we have to subtract these parts. It means the length should be now 12 feet minus that thing. If you remember, what we have done is actually that was 13 inches, and here this length, it was sorry, the weight, that was 9 inches. Okay, so we will subtract that 9 inches from 13 inches. Okay, this is clear, I think. Is it clear now?
Yes, sir.
Okay, so we have 12 minus that ratio. Now the length should be 11.667 feet for the short wall. Now I'm again going to share the screen, which is this thing.
Yes, sir.
So the length of the short wall that is just 11.667, if you remember. Okay. Now the quantity can be the same thing. Okay. We can just copy that formula. Okay. Just by Control C, and we will just paste it over there as a special, maybe as a form. Oops, sorry. We can just paste a formula as well, but no problem. Let's have the formula again. Maybe this times the length, okay, times the width, and times the height. Now the height cell that is just hidden because of those formulas, so I can specify that by the name, okay? As you can see, the column is F, and the row that is 4, so I can say F4, and I'll close the bracket. Now the total excavation is going to be, okay, we have total excavation, and that should be actually the summation of the above two. So we can just select with extra cell and just click this summation. As you can see, we have 82, okay, CFT.
Yes, sir.
So we have calculated the excavation. Now the other things, those are very simple. Very simple if you have learned about the excavation, okay? Next, we have actually number 2, and that's going to be, just a minute, that's going to be this PCC work. As you can see, we have PCC work, and that is 3 inches thick, if you see that, this one, okay? So it means PCC work in foundation, and that is, let me just have some correction, maybe wrapping. Okay, we have PCC work and foundation, and let's say that is 1:4:8. Now it is the same thing. Okay, we will have to determine for the long wall and then for the short wall. Okay, let's say first I'm gonna take long wall, and then we're gonna have short walls. Okay, now long wall, those are 2, short walls are also 2. The length of the long wall, if you remember, it is the same thing as that one, okay? The length is just the same. The width is just the same. The height is just difference, okay? There is a difference in the height, but just a minute, I'm gonna show you that, how that is just difference. All right, now look at this point, okay? The weight of the foundation is the same as the weight of the PCC work. Is that clear? You can see that, okay? This is the PCC work, and the weight of the foundation is 13 inches. So the PCC work that is also 13 inches wide. However, the PCC work is just 3 inches, but the foundation that was just, you can say 18 inches, which is just 15 inches plus 3 inches. Okay, so that is only 3 inches. It means the PCC work should be 0.25, okay, and 0.25 for the short wall as well. Okay, and here we have to just use the formula. Okay, I'm just gonna have the formula. Okay, let me just copy this cell, and here I'm going to paste it. Okay, so these 4 things. Okay, if you are confused, if they are not correct, so you can just double click, and as you can see, all the cells are just selected. It means the formula is okay. Now you have to just drag this formula to the wall A, just like that. Okay, so this is now the PCC work in the foundation. Okay, we have to calculate the total PCC work in the foundation, and just by selecting an extra cell, you can say, and that is 13.8 CFT. Now, what do you mean by these things? Okay, like 82 CFT is excavation, 13.8 CFT is PCC work. Okay, this is just like you can say nothing important. It's very important, because in estimation or quantity surveying, we do calculate the cost of the project. Okay, how the cost of the project can be calculated? Okay, because of the materials, because of the cost of the materials. Now, as you can see, the total PCC, that is 13.8. It means there are cement in this 13.8, there are sand, there are coarse aggregate, okay, water are used in the same PCC work. So we have to use analysis and just determine those things, cement, sand, crushed stone, okay, from 13.8. Is that okay? Now, about excavation, that is 82 CFT. What do you mean by this? Okay, For excavation, of course, we need labor, maybe equipment, okay? And labor and equipment, they actually cost us, okay? Because labor do not work for free. You have to pay them, okay? So those all things are just included in the cost of the project. So before we have to calculate all these things the same way in terms of volume, in terms of area, okay, in terms of number. Now, it is also important how many labor should we hire for the same excavation work? That is a very good question, okay? And there is actually a special table for that. I'll share it with you, okay? When we are just determining the you can say, or we are doing analysis for the same PCC or maybe excavation, okay? All right, now above this, as you can see, we have stonework, right? So number 3, we have stonework in Excel, and I'm gonna say stonework in cement mortar, and that mortar is, let's say, 1:3, and I can even write the text. Now, again, I'll be just calculating all these things, okay? So I can even just copy them because of this similarity, okay? Everything are just similar over here. So I can copy those things, okay? And let me just paste them maybe like over here, okay? For the long wall, for the short wall, only the thickness may be changed, right? And that is because, as you can see, just look at over here. The foundation width or thickness maybe, okay, that is just the same as the foundation's width over here, okay. I mean, the weight of the stonework, that is just the same thing as the foundation width, 13 inches over here and 13 inches for the stonework, right? It means if the data is just the same, it means the length is going to be the same, the width is going to be the same, only the height is going to be different, which is actually 15 inches and 12 inches. What do you say?
सर एक दफा
सर
रिपीट
ये
कर
Okay. Okay. Just look at this thing, okay? The linear, and as you can see from this point till that point, we have the stonework, which is 2 feet and 2 inches. And as you can see, the width of this thing from that point to that point, that is actually 1 feet and 1 inches width, which means 13 inches. Okay. So it means the weight of the stonework is just the same thing as the weight of the foundation. The only thing which is different is actually the height of the stonework. Okay. This is the height, and which is just shown over here. That is 12 inches and 15 inches. However, as you can see, DPC is also included over there in the 12 inches, okay? So we have to subtract 1 inches DPC. You can see that DPC is 1 inches. It means the height of the foundation, I'm sorry, the height of the stonework is now 15 inches and 11 inches. So
सर
DPC
वो तो
is
12 इंचेस में नहीं आएगा ना, वो माइनस करेंगे हम.
that's what I'm saying, that we have to take 11 inches, like maybe 15 inches
Yes.
plus 11 inches. That is just 26 inches. You have to divide that by 12 to have the height in feet. It's very simple. And that is going to be just, you can say 2.1667, okay, for both. And the formula was just pre-applied. So this is 64 and 54 as the stonework, okay? And this is actually the summation and CFT. So we have stonework is, you can say that is how much? It is 119.673 CFT, okay? Now from this stonework, further we have to just determine the, maybe as you can see, this is in cement mortar, okay? So it means there is sand, there is cement in the same stonework, okay? But this is not our approach this time. That will be done very, very late, okay? Number 4, and that is actually the DPC work, okay? So I have to just copy these things, right? If you don't mind, I have to copy these things and I'll just rename them, okay, with TPC. And that is just 1 inch thick TPC. and maybe the DPC can be concrete DPC. Okay, you can also mention that concrete DPC. You can also mention the ratio. The ratio is, let's say, 1:4. Now, for the long wall, for the short wall, it is just the same thing, okay? As you can see, the TPC is over here, over there, and on the, if you just, let me just delete this thing, okay? So, okay, we don't have to delete. As you can see, this yellow represents, let's say, the DPC for the long wall. And over here, this represents the DPC for the long wall again. However, the DPC for the short wall can be this thing. Okay, let me just change the color and let's just draw a rectangle so you guys can see it. You can see it maybe to green. Okay, so this green rectangle represents actually the DPC for the short wall. And that should be actually maybe 12 feet. Okay. Now, the long walls, those are 2n number. The short walls, those are 2n number, right? However, if you look to the same thing, the weight of the DPC, that is just the same thing as the weight of the foundation or maybe the weight of the stone wall. It means there should not be any changes in the length, okay, for the long wall and for the short wall. However, if you see the thickness of the wall, that is just, you can say, different from the thickness of the foundation. That means while calculating the brickwork in the same wall, the length for the long wall and short wall will be different from the length of all these things. So let's see, right? However, as you can see, the thickness should be just removed. What do you guys say? Because DPC is always calculated in terms of area, okay? We don't calculate DPC in terms of volume, okay? It is calculated in terms of area, and that is because the thickness of DPC is always very minimum value, okay? We have to just change the formula because one column is just been removed. Okay, again, over here, we will subtract the last column, okay? Now, this is going to be SFT, or you can say square feet. So this is just the quantity of DPC. Now, we will just move ahead for the quantity of the brickwork. Okay, let's say number 5, and let's say that is brickwork superstructure. SS means superstructure. Superstructure means the structure which is just above the plinth level. Okay, and let's say that is in ratio 1:3. Now, there is actually long wall and short wall. So let me just copy and paste them as well. Now, long walls are 2, short walls are 2. That is just clear, okay? You can see it is clear. These 2 yellow are, you can say, long walls, and the short walls are just remaining, like maybe the short walls are wall A, okay? This one, and on the right-hand side, there's also a wall A, you can say. Now, the length this time is going to be different, which was already been calculated. If you guys remember, maybe, okay, we have done that. You can see that, okay? So let me just use maybe the AutoCAD so you guys can see it. I'm gonna go to the annotate, and here is linear. Now, the yellow portion represents the long wall, and that is 13 feet and 6 inches, okay? Here, the green, that is actually short wall. That is 12 feet. You can see that. Okay. So 13.5 for the long, and for the short, that is only 12, which never changes. Okay. Now, the thickness of the wall, that is just shown. Okay. Maybe in the drawing. This is a brickwork. Okay. Maybe 9 inches. It is not just annotated over here. Let me just check if it's 9 inches. Okay. It's 9 inches. Pretty cool. Okay. So that's going to be 0.75. 9 inches means 0.75. Okay, is that clear? Now the height, let's just check if the height is over here. As you can see, it is 11 feet. Okay, so I'm gonna have height of the brickwork. This is, as you can see, a brick wall, so the height is 11 feet. Okay, again, let me just put those videos over here. 11 feet and 11 feet. Now we have to just copy that formula and paste it over here. Okay, and you can see this is the same thing as brickwork. I'm gonna drag that down Okay, and let's just have total brickwork. BW means brickwork. I'm gonna have extra column over there and the summation. So this is in CFT, right? I'm gonna add the other things, maybe like borders to the other cells. So we have calculated almost five materials. Okay. Next, we have actually maybe you can say the roof. Okay. Let's just calculate the roof, right? Number 6, and that is actually RCC slab maybe. Okay. And let's say the RCC that is 1 to 4. Is that clear? Now the RCC slab is only one because it is just a single room, right? Now the length of the RCC that should be actually, if you see, that is just extended. You can say one feet is just the chajja or maybe extension to one side and another side. Okay, and this is actually the length, which is 12 feet. And as you can see, it is square. Okay, it means the size or maybe the both sides should be the same. You can say breadth and width. Okay, let me just have dimension, and as you can see, if I just check it over here from this point till that point, that is actually 15 feet and 6 inches. And how? Okay, let me just show you how it works. As you can see, we have 12 feet over here. Okay, 12 feet. So for both sides, I'm gonna add 9 inches, okay, for one side and 9 inches for another side because the wall thickness is 9 inch. Okay, as you can see, 1 feet for one side and 1 feet for another side is chajja or maybe extension. Okay, so 12 feet and 1 feet and 1 feet. Okay, it means 2 feet addition. Okay, for the chajja, that becomes 14 feet. Okay, and 9 inches for one side and 9 inches for another side, it becomes actually 9 and 9, that is actually 18 or maybe 1.5 feet. Okay, so 14 feet plus 1.5 feet, that becomes actually 15 feet and 6 inches. Okay, so this is going to be the length of the RCC slab. Okay, that is 15.5, and the width is going to be 15.5 because this is just square. Now the height is 6 inches. Oops, it is only 5 inches, I think. Okay, it's written over here, okay? That is just 5 inches. So you have to just divide that 5 by 12 in order to have that in, you can say, feet. And that is actually 0. Maybe 416. We have to copy the formula. That is 99. It's a CFT, sorry. It is CFT because this is maybe you can say RCC work, okay, in terms of volume. Okay, so slab is done. Now the floor is remaining. As you can see, we have floor over here.
सर इसमें अगर आपने हाइट ली है तो डीपीसी में क्यों नहीं ली 1 इंच?
Because DPC, the height of DPC, that is very minimum, okay? While we analyze these things, maybe in the analysis, okay, you will learn that thing over there. In the analysis, we will convert this DPC's area into volume. That time, actually, we will multiply the thickness of the DPC with the area of DPC, so we can have the volume of DPC.
Okay.
So in the analysis, we will actually have consideration for the thickness of the DPC. This time we are just ignoring the thickness of DPC. Okay, very simple thing. Okay, two things are remaining: just the floor and then the plaster work. Okay, and I think an hour is just completed, so we will just continue this thing from this point. Are you guys agree?
Yes, sir.
Allah Hafiz. See you tomorrow, inshallah.
See you.
Tomorrow is actually just a minute. The class will be morning time, okay? Chalo, you are good to leave the class. See you inshallah tomorrow. Allah Hafiz.
Inshallah.